Can you get this GMAT data sufficiency practice question right? Because 91% of people don't. I'm Erika, and today I want to share with you the hardest GMAT data sufficiency practice question in the Target Test Prep program. This question was designed to be challenging, and it is, with only 9% of students getting it right. I'm going to show you how you can be one of them. Let's jump in. All right, if you want to give this question a go on your own, pause the video here. Now, before I get started, I'm going to go ahead and get rid of all the language from these answer choices just to give myself room to solve. Now, if you're watching this video, you should hopefully already know these by heart, so it shouldn't be a problem. Okay, giving the question stem a quick glance, I can identify that this is a rate question, specifically a distance rate question, and even more specifically, an average speed question. This means there is a good chance I'm going to be working with my average speed equation, or total distance over total time, which for a two-leg trip like this is going to be distance 1, or the distance from the first leg, plus distance 2, or the distance from the second leg, over time 1, or the time from the first leg, plus time 2, or the time from the second leg. All right, digging into our question stem, William drove from town A to town B and then drove along the same road from town B back to town A. Okay, pause here. Since William drove the same route on each leg of the trip, we know that D1 is going to be equal to D2. That's nice. I'm going to go ahead and rewrite my expression accordingly, subbing in D1 for D2, which allows me to rewrite my expression as 2D1 over T1 plus T2. Continuing on with my question stem, was William's average speed for the entire trip at least 60 miles per hour. So this at least tells me that I don't actually have an average speed equation. I have an average speed inequality. Is my expression for average speed going to be greater than or equal to at least 60 miles per hour? So this is a yes/no data sufficiency question, which means that I am being asked whether I have enough information to determine whether the answer to my question is yes or no. So for this question, is my expression for average speed greater than or equal to 60? Is my inequality true? Yes or no? So if I can definitively answer yes, my inequality is true, then the information I'm using is sufficient. If I can definitively answer no, my inequality is not true, that is also sufficient. It is only insufficient if I can get either a yes or a no. Important to remember what we're doing in a question like this. All right, at this point, we can jump into our statements. Now, before I approach this the right way, I want to show you the trap that most test takers fall into. Okay, statement 1 tells us that the distance from town A to town B is 117 miles. Okay, gonna go ahead and do my work for statement 1 right here. This means that D1 is equal to 117. So I could plug this into my inequality and I could solve for the numerator, right? But without either T1 or T2, I have no way of determining whether this is true. So statement 1 is going to be insufficient, which means that I can rule out A and D. Moving on to statement 2. Okay, William's average speed while driving from town A to town B was 30 miles per hour. All right, this is the first leg of my trip, so average speed is going to be distance 1 over time 1, and it is going to be equal to 30 miles per hour. All right, here's where things fall apart. At this point, most test takers go, okay, I have the ratio of D1 to T1, but I don't actually have either value. And even if I did have either value, that's just 2 of the variables in my expression. I still don't have T2. So if statement 1 was insufficient, statement 2 is really insufficient. And that means that I can rule out B. And in fact, even if I take both statements together, sure, I can plug my information from statement 1 into my information from statement 2, and then I can have both D1 and D2, but I still don't have T2. So even together, both statements are going to be insufficient. I can rule out C, and my answer is E. This is wrong. And the trickiest thing about this is that there is absolutely an easier average speed question, an easier distance rate question that can be solved using this exact method. Most students are probably patting themselves on the back for saving some time, not doing a bunch of calculations as they are submitting this incorrect answer. But we can save ourselves because this is a hard problem. And for a hard problem, it's suspiciously easy. So if you know you're a high enough scorer that the test algorithm should be feeding you hard problems, the ease that we've had so far in solving this one should set off alarm bells. All right, looking at statement 1 alone, let's go ahead and plug 117 in for D1 in our inequality. So that's going to give me 2 times 117 over T1 plus T2 is greater than or equal to 60. Or multiplying that out, 334 over T1 plus T2 is greater than or equal to 60. Okay, now since we know that T1 plus T2 is positive, we can multiply it on both sides without changing the direction of our sign. So that's going to give us 334 is greater than or equal to 60 times T1 plus T2. Okay, dividing by 60 on both sides is going to give us 334 over 60 is greater than or equal to T1 plus T2, or about 5.5 is greater than or equal to T1 plus T2. Okay, is that inequality true? Well, maybe. We have no idea what the values of T1 and T2 are. They could be, say, 2 and 1, and the answer would be yes. But they could also be 2 and 4, and the answer would be no. So this one is definitely insufficient. We can safely re-rule out A and D. Okay, let's check statement 2 on its own. All right, working with this ratio, I can rearrange by multiplying by T1 on both sides to get D1 equals 30 times T1. All right, plugging that into my inequality, I'm going to get 2 times 30 times T1 over T1 plus T2 is greater than or equal to 60. Or multiplying that out, 60 T1 over T1 plus T2 is greater than or equal to 60. Once again, we know T1 plus T2 is going to be positive, so we can multiply it on both sides without doing anything to our symbol here. So we're going to get 60 T1 is greater than or equal to 60 times T1 plus T2. All right, dividing by 60 on both sides, which again, I can do. It's positive. It's not going to affect the direction of my inequality. I get T1 is greater than or equal to T1 plus T2. Subtracting T1 on both sides, I'm going to get 0 is greater than or equal to T2. And then flipping that around just to make that a little easier to parse, I get T2 is less than or equal to 0. So, okay, is this inequality true? Is time 2 less than or equal to 0? Oh, hold on. Can the time that it takes for the second leg of our trip be 0 hours or negative hours? Can we drive a place in 0 time or negative time? Well, that's actually impossible, right? It takes time to get places. The minimum possible value for either of our times is going to have to be positive. So I definitively know that no, T2 is not less than or equal to 0, which means that no, my inequality is not true, and my expression for average speed is not greater than or equal to 60, which means that statement 2 alone is sufficient. Remember, an answer of no is just as sufficient as an answer of yes, as long as it is definitive. That is the only possible answer, no. Which means that statement 2 alone is sufficient to answer the question. And the correct answer to this one is B. Not E, not even C, B. So in order to get this question right, 1, we need to be familiar with average speed and the concepts behind it. 2, we need to be extremely confident in yes/no data sufficiency questions and what they mean for sufficiency. And 3, we need to be wary of when problems seem too easy. Go back and ask ourselves, what's the trap? So did you get this question right? Let us know in the comments. And if you'd enjoy more hardest question videos like this one, give this video a like. Thanks for watching, and I'll see you in the next one.